Alrighty. So when we're working with converting it to vertex form, that's when we're going to need our formulas that we used on Friday, where we have our axis of symmetry is our x equals the opposite of b over 2a, that guy. Because we're trying to get this into our vertex form to graph it. So to find our axis of symmetry, the x value of our vertex, we come in and we get our opposite of the b value. What is our b value? 4. Over 2 times a, and what's our a value? 1. So we have the opposite of 4 over 2 times 1, or negative 4 over 2. What does that simplify down to be? Negative 2. So the x value of my vertex is negative 2. To find our y value, we're going to substitute in y equals negative 2 squared plus 4 times negative 2 minus 12. Substitute it into the whole equation. And we can use our calculators for that to get our negative 2 squared being 4 minus 8 minus 12 should give us negative 16, I believe. So our vertex is the point, minus 2 minus 16. Yep. And so I actually can't graph it on this grid. Love that. Love that so much. So when it comes to trying to graph this, when we do our table, we put our axis of symmetry in the middle. Our negative 2, we pick some smaller, negative 3, negative 4, some bigger, negative 1 and 0. And I cannot actually, we're just going to extend it. And 0, trying to get our graph. So there's our vertex. You know, it helps if I probably put it in the transformation form so that we can get our A, H, and K, so we can do our transformations. Sorry, it's Monday. My brain's kind of stuck. Y equals x minus our H, minus our x value of a vertex, minus negative 2, becomes x plus 2 squared minus 16. And our A value, we talked about it already in our axis of symmetry formula, that's a 1. To get our Y values from our vertex form, we have a couple of options. We could just plug and chug. You could take these guys and throw them in through our calculator. Or we come over here and remember our Y times A plus K and do it from our parent table. Either way is fine. We're going to wind up with stuff that's almost entirely off our graph of negative 15 on both sides here and negative 12. And honestly, most of these don't fit on my graph. And negative 4 has a negative 12. Negative 14, so it's going to be somewhere here and like that. Should look something like that. And again, you can do the filling in of the table either with our y times a plus k, use the parent table just like we did just before fall break, or you can plug and chug, take those y values we found on either side of our vertex, plug them into the equation. The graphing is not the new part, but it's one of those things that is going to be helpful to remember from before break. What's up?
That's me. Good morning.
Good morning.
How are you doing today?
Doing good. How are you? Oh, thank you.
Welcome.
Presidents. We love a snack. All right. Questions on our bow work. All right. Yeah, I know it's 7:30 on a Monday and we're mathing a little hard, but we gotta do what we gotta do. Today we're gonna be using our calculators a bunch. Bunch. So I'm gonna grab the third bin of calculators out. If you don't have a calculator, grab one. We're gonna use calculators a bunch today. A bunch to crunch up. In fact, I'm gonna open mine up on the screen. Because what we're gonna be doing today is doing the quadratic formula. And the quadratic formula is a way to solve a quadratic, to solve an x squared, that works guaranteed 100% of the time, every time. It's just the most calculatory of all possible options. It will always work. It is just also very, very, very mathy. Okay, so factoring is probably the fastest option. Putting it into complete the square or vertex form is a fairly soft option if we can't factor, but quadratic formula, while the most calculatory of the steps, will work every single time, 100% of the time. It just requires us to have this formula. It will be given to you on the test. However, we have to know how to use it. So write this down. If you ever care to memorize it, there are about 50 songs on YouTube for how to memorize it. The classic one is Pop Goes the Weasel. X equals negative b plus 2 minus the square root of b squared minus 4ac all over 2a. Like there, it happens. It gets used often enough that people memorize this. There are remixes where someone's taken a Dre song. Like some of them are bad, but in that really trash, like really good kind of way. So if you're ever like in a YouTube hole and you're like, I have nothing to search for quadratic formula songs. Some of them are so bad they're good, and so good they're bad. Like, oh, there's just levels of crazy for it. But we don't need to memorize it because anymore we kind of give you these formulas. This is one of those things that you used to spend like a couple of days working on your memorization for it. When I did quadratic formula the first time in my 8th grade class, we chanted it and marched around my school chanting the quadratic formula. It was a very, very small school, so we would march past the kindergarten classroom chanting this like a creepy little cult. Just a bunch of 8th graders chanting opposite of b plus or minus squared. Creepy. Math people. Okay, so what this is we're going to be using the A, B, and C. Like those same A and B and C. Those same guys, how we do the opposite of B over 2A for our axis of symmetry. We find our A times C and our B for our factoring. The same A, B, and C guys. And we are going to plug them into this quadratic formula. And it's with that plus or minus, this gives us our 2 roots. So we're going to practice this. And here's our first one. And I'm going to show you how to do it. I'll show you every step. What we're going to start with is identifying A, B, and C. I'm going to switch this out so you don't have to zoom in with me. So what is my A value? 1. What is my B value here? 4. What is my C value? negative 17. So what we're going to do is we are going to take this quadratic formula that's over here. I gave it to us up here. And we are going to take our A and plug it in where there's A's. We're going to take our B and plug it in where there's B's. We're going to take our C and plug it in where there's C's. It is substitution purely. I'm going to have to stay back to accept. Oopsies. So what we're going to have is x equals, and I always draw my big old fraction line first. And I am going to do color coding like crazy pants right now. So we have our opposite of b, which I have as blue, which is 4. Plus or minus the square root of b, which is 4 squared, minus 4 times my a, which is 1, times c, which is negative 17. And my denominator is 2 times my a, which is 1. This is the step where you need to stop and take your time the most. If things don't get substituted in correctly, you got no chance. Get your B's where they need to be. You should have 2 B's, 2 A's, 1 C. Ideal report card. From here, what we're going to do is simplify. And theoretically, yes, you could type this whole thing into a calculator, but holy cow, is it easy to make mistakes when we do that. So what I'm going to have us do first is we are going to simplify the guy under the radical. He has a special name. He has things he can tell us. But what we're going to do is we're going to take this. This is called the discriminant. And I'm going to simplify that first. And I need another color marker. So what I'm going to do is I'm going to type that in the calculator. We've got our 4 squared minus 4 times 1. And I'll do it on the screen, I promise. I'm just writing it down so I don't forget it. There we go. So we're going to take our 4 squared minus 4 times 1 times minus 17. And we can type that piece in here. So under the radical, we're going to have a positive 84. So this tells me we have x, ooh, wrong pen. X equals the negative 4 plus or minus the square root. And what we got on the calculator was that this piece equals 84. So under the radical, we have an 84. And my denominator is 2. Does everybody see that part? We simplified this so that we could simplify this way easier. Because now this, I can type in a calculator easily, competently, and very easily see if I make any mistakes. It's much easier to do this into 2 parts than in one giant part and just assume we've typed everything correctly. Because what we're going to do is we're going to simplify this. And we're going to simplify this into simplified radical form, which you can absolutely do by hand, but we can also do with our lovely calculators because they are our very bestest friends. Oops. I gotta just marking things down. And what we're going to do is we're going to go to the calculator. And we're going to put this in to get our simplified answer. And we're going to start with hitting the fraction button. Second column, third button down gives us a fraction. And on the top, we're going to put negative 4. For negative, we use this bottom down here. Negative 4. And then we have that plus or minus. There is not a button on my calculator that says plus or minus. So what we're going to do is we're going to do it once with a plus, We're going to do it once with a minus. So I'm going to start with my plus square root of 84 over 2. I can see here that I've typed things correctly. If I tried to type all of this gobbledygook into my radical, while the calculator can do it, it's really, really hard to make sure that I typed it in right without looking at it. And what this is going to do is this is going to give us our simplified radical form. Because it takes our radical and simplifies it, and it takes our fractions and simplifies it. So one of our answers is square root of 21 minus 2. We're going to do the same thing with the minus sign in our fraction. So we're going to come back in here into our fraction. Not that. Negative 4 minus the square root of 84 over 2. And we get negative square root of 21 minus 2. And again, there are ways to do this by hand. But we don't necessarily need to. So this is a radical form answer. These are our simplified radical form answers. We need 2 answers. To get a decimal answer, what we're going to do is we're going to go back to the calculator. And so I'm on my second one, my minus sign one, and I'm going to hit the double arrows right above the enter button. And it gives us the decimal form. For the most part, we're going to go with 3 decimal places unless I tell you otherwise. Okay? So we can assume 3 decimal places. 1, 2, 3. So negative 6.583. Because if I cut it off here, I got to round this guy up. So that's our approximate decimal answer for the bottom one. Let's go back and grab the approximate decimal answer for the top. That was our square root of 21 minus 2. Make sure that the minus is outside the radical. And we want our decimal version, so we hit the 2 arrows, and we get 2.583. So quadratic formula works if I have real roots. Quadratic formula works if I have irrational roots like this, where we have square roots in it. Quadratic formula is going to work even if we have imaginary roots. It will do it all. It's just kind of the most complicated and finicky to do. Questions on this first one? Because we're going to practice it again. Once we get the hang of it, though, it is simply substitution. We just got to make sure we're substituting in the right pieces. So here's our next equation. And it gave us the quadratic formula back again. So first thing I need to do is I need to find out what is A. What is A? 5. It's the number in front of my x squared every single time. What is my B? 8. And what is my C? 11. Start with identifying A, B, and C. Then I'm going to substitute absolutely everybody into our formula. It's up there in the top right of the screen. X equals the opposite of B, which is 8. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So just typing it in is our step 1, or just writing it in. So then what we're going to do is we are going to simplify this piece. I'm going to take this chunk and type it into my calculator. The piece under the radical, that is the part we want to simplify first. That is, again, it's called the discriminant. But we're not going to go super deep into the discriminant and what it can tell us. We're just going to type it in. Where I have my 8 squared minus 4 times 5 times 11. You'll notice whenever I do substitution, I put it in parentheses. It's a good habit to be in. It helps us keep track of signs. So what we get is negative 156. So this guy, this chunk under the radical, is negative 156. So when we come down to our next part of this, negative 8 plus or minus the square root of negative 156 over 10. What's going to happen with that radical? Can I get square root of negative 156? Can I type that in the calculator? What? Why? What's that mean? What's this minus sign gonna do to it? It's I. Yeah, we're gonna have imaginary roots here. So when we're looking to simplify this into our radical form, what we can do is we can go, all right, the negative 8 and the 10 are hanging out. We're going to have our plus or minus. And to figure out what the square root of 156 is, or negative 156, I know it's going to give us an I. So we're going to have our I. And then I can simplify 156 this normal way. Square root of 156, for sure. 2 square root of 39. So I times 2 square root of 39. And I have a wiggle. And since we have an I here, we're not going to get decimal numbers. But what we can do is I can notice that I have 8 over 10 and 2 over 10, and I can simplify both of those fractions. This is what the calculator was doing for us on the first one. So our best answer, our fully simplified radical answer, is because 8 over 10 is they're both divisible by 2. I'm going to have negative 4 fifths plus or minus, and the right-hand side, 2 over 10, are both divisible by 2. I square root of 39. Because I can take 2 out of the coefficients. Don't divide it out of the radical, just divide it out of the coefficients. Just like if this was 2x, I could divide the 2 out. Doesn't matter what this x is, even if that x is ugly. I can divide the 2 out. And we're just getting 1. If you want to do it as 2 separate fractions, I'm okay with that too. Totally fine. But since it's imaginary, we're not going to get a decimal answer because it's not real. So we're not going to go for decimals here. This simplifying step on the very bottom, we had the calculator do on the last one. So if you have real numbers, have the calculator do it for you. Way easier. But if we have imaginary numbers, we are going to have to do it by hand. Questions on this one? One more, and then I'll give you a worksheet to practice it. And it's going to look like a story problem because it's from the book. So here we've got the pumpkin chunkin contest, or pumpkin chunkin, which is actually a real thing, where they take a catapult and launch pumpkins. It's actually kind of cool. So they have this equation here, where h is the height and t is the number of seconds. So we're asked to use the quadratic formula to solve this equation. The context changes nothing about what goes on here. So we are going to substitute these values in to the quadratic formula. I've got my a being negative 16, my b being this horrible, horrible decimal, and c is 42. And we're going to substitute these values in. X equals the opposite of our b value, which is that 124.4 plus or minus the square root of 124.4 squared minus 4 times our a of negative 16 times our c of 42 over 2 times our a of negative 16. So we start with just substituting in the values that we're given. And then we say, ew, super gross. And we start to type pieces into the calculator. Again, we don't want to have to do the whole thing in one go because it's way too easy to make mistakes. So we're going to do it in pieces. And I'm going to take the piece under the radical, the discriminant. And we're going to take that guy first. Bless you. So I'm going to take this piece under the radical. I have to clear my screen. So I have 124.4 squared minus 4 times negative 16 times 42. Oop, I missed in parentheses. There we go. It's much easier to look at things like this and fix and edit here than it is to do the whole gargantuan thing at once. So we get a really, really gross number. 18163.36. We have, ooh, wrong pen. There we go. X equals negative 124.4 plus or minus the square root of 181.63.36 over negative 32, because 16 times 2, which looks objectively horrifying. We're going to just hop straight into decimal form here. So I'm going to take it, we're going to do the plus, and we're going to do the minus. So I'm going to go back to my calculator, and I'm going to do my fraction, second column, third one down, negative 124.4 plus the square root of that hot mess, 181.63.36 over negative 32. And we can just type the whole beastie boy in. And since it's gross enough, even the calculator goes, ew, and hops straight to decimal form. So you have negative 0.324. Negative 0.324. We're going to go back and do the plus, and I'm going to show you a shortcut on this. Instead of having to type the whole dang thing back out, I'm going to hit up, up, where it highlights my problem. Then I'm going to hit enter, and it copied it. So then all I got to do is go back enough times to get to that plus sign, switch it to a minus, and rock and roll. So you can absolutely type the whole thing in, but there are shortcuts we can take, and we've got 8.099. And then, so we have our two solutions here. These are the two solutions for the quadratics. These will be how our answers tend to wind up when we deal with real world situations, because the real world doesn't wind up with whole numbers because the real world is gross. So if I asked you how far the pumpkin went, or how long the pumpkin was in the air. How long was the pumpkin in the air? Which of these answers make sense? Because our x is this variable, the t, so t is seconds. So which of these makes sense as an answer? The bottom one. Why does this one not make sense? Because it's negative. Negative time means that pumpkin landed half a second before it launched. That sucker fell out the catapult. I don't want that answer. That's not what we want. I want to know where did it land over there. Okay, so the negative answer does not make sense. This one is not logical. We're going to say not logic because otherwise I'm off the edge of the screen. But it's not logical. So this is our answer. So occasionally on things like story problems, it's just a matter of, does it make sense for the negative answer to be a thing? And if it's a location, maybe we can make the argument about going backwards. If it's time, you just made a time traveling pumpkin. Wow, cool. Not a thing. Okay, so what we're going to do is I have a few of these for you to practice with. Shock of all shocks. Homework 3-6. There's only one more homework this week. Because we have a quiz on Friday. That is the wrong date. Because that's called, I haven't updated it. No. So our next quiz is Friday. This Friday. 27th. That's the wrong date on there. Okay, so these are all quadratic formula. They don't get worse. Okay, the decimal one we did today is as bad as they get. So they don't get worse. Okay, we've got 8 minutes until announcements start. So you've got some time to work on it. Give it a shot. Use the calculator. Practice using the calculator. I'm going to change this date. I'll get you guys a chapter review here probably Wednesday.